Okay, hello. So today we will start a new topic, and it has to do with session and authentication, because so far we already know how to deal with the roots, how to deal with the implementation of certain functionalities, but we all know that in a typical web application the functionalities are not available for all the users, but they are restricted depending on the user, depending on what are the roles for a given user. So without authentication, it's hard to think in a realistic web application. So today we will see what the sessions and the authentication is, how it works, what are the concepts involved in that, and then in the second half I'm expecting to do a demo so that we can practically see how to implement the authentication into our Flask stack. Then, just as an announcement, this Friday we'll have the authentication lab, and next week you will have a lesson with the Professor De Rusis, okay, and you will have the lab with him. So the slides are already available if you want to download them and follow them from here. Okay. So in this first half, the idea is to understand what a session is. I don't know if you have seen that concept somewhere. We will learn how to use Flask login. That, as you can imagine, is a library that is already implemented and that we can adapt and we can integrate into our application, and how to use it to manage the user authentication. We will implement the typical functions concerning authentication that are login, logout, and the user session persistence. And we, of course, are going to see how to protect the roots. What do you think protecting the root means? Basically refers to the fact that some roots that we have already defined in our Flask application will not be available or publicly available for everyone, but just for the login users. Okay? So that, for instance, now creating a new appointment with the tutor is not a function that we can use or invoke just by going to the page, but it will be available for us just if we are authenticated users. And finally, we'll see how to handle the unloading the sessions and the sessions management properly. Okay, so here is the scenario. We have said so far that we are always using HTTP requests, no? And that web applications are built upon HTTP requests. What are these HTTP requests? They are the requests that we send from our browser to a remote server, and that remote server retrieves us what? What do we receive in a HTTP request? The web page. Basically the HTML or the response. There is an issue with this schema because by definition HTTP is stateless. What does it mean to be stateless? That it doesn't remind us. It doesn't have memory. Okay? So each time I send a new request, it's a completely new request. He doesn't remember me. He's not able to identify who has made the request before, or he can't remember which are the requests that I have been sending to him. So each time he receives a new request, it's completely unlinked from the previous one. So each request is independent and it doesn't retain information from previous interaction. This is an issue because in a web application we want the server to remember the users, no? So for instance, if you think of a shopping cart, Amazon for instance, have you seen that when you add something to the basket case, and then you leave the page and you get back to the page, he remembers that you have added one item into the basket case? or if you have logged in a website, it is not that each time that you ask something else from the server, you have to authenticate again. He's able to remember you, that you were authenticated, that you were already there, and you don't have to authenticate each time that you make a request. So in practice, this schema doesn't work because we need to remember who the user was and keep a state of the communication between the server and the user. So here, in this context, is why we need the sessions. So what is a session? It's basically a temporary and interactive exchange of data between two or more parties. In this case, it's the client and the server. It involves, or it spans across several messages. So one or more messages sent in each direction, being the direction the server and the client. Typically, one part maintains the application state during the session. Who do you think keeps the application state during the session? The client or the server? The server, no? Should be the one that keeps track of the users, that keeps track of the state of the users, of the authentication, of the privilege that a given user has. So well, it's typically the server. And a session has a defined beginning and ends at a later point. So I don't know if, for instance, in these kind of applications, Amazon and the applications that you log in, you have noticed that after a given time, you are disconnected. Okay, so that you log in or that he remembers you, but after some time, he lost that information. And the reason because of why that happens is because the sessions have a defined beginning and a defined end. So at some point, they get lost or they are not valid anymore. Okay, and if we try to think a session-based authentication, I mean, a session can be used to keep track of any data and to exchange data across different HTTP requests. That's the definition of a session. In our context that we are talking about authentication, the sessions are like the way of implementing the authentication, no? It's one possible use of the sessions, and it's the one that we are going to exploit and that we are going to study, and it has to do how to use the sessions to authenticate a user. Why the sessions are useful for authenticating a user? Because they are the mean that we have to exchange data and to keep the state across different HTTP requests. So conceptually, how does it work? I think it's pretty explainable. It's easy to understand. So I think we all have I think we are all familiar with the process because in every web application or it works with authentication typically. So it usually starts when the user fills a form. We already know how to create a form with a username and a password in the client application, meaning on the browser. Then the client validates the input and, if valid, sends it to the server through a POST request. So up to that point, check, because we already know how to do that. What do we understand here by validates the input on the client side? Like the, yeah.
Some limits, like for example, only letters.
Sure. Yeah, like the typical validations we have been doing so far, that a field is required, that if we are expecting the email, then the field must be an email, that it must have a minimum length, a maximum length. So the typical validations that we already know how to implement on HTML. And we send a post request. So in this point, we are here with the user sending something to a server. What does the server has to do? He receives the request, and of course, in the database, he checks if the user exists. No? Because if I want to authenticate, the server has to check if that specific user already exists in the database, and if he exists, he checks the password that has been sent from the client to see if it matches. So verifies the password using cryptographic hashes. We will see this concept later, but okay, for now, let's keep in mind that he verifies the credentials. If the user is not found, if the user doesn't exist, or if the password doesn't match, he responds with an error. But if the user exists, what the server does is he creates a new session ID. That is a special kind of session or a specific type of session. So he creates this session ID, and he saves that information on the server side. Okay? It's like he's creating a key, and he's keeping track of the key he has created. Okay? So he created the session ID, and the session ID with some information retrieved from the database is stored in the server session storage. So he remembers which sessions ID he has created. Why? Because now the server sends back the HTTP response, but the HTTP response in this case is not just the HTML or the HTML, but he also retrieves a cookie. Okay? And what does the cookie have inside? The session ID. Okay? So it is, let's think of this like I am the server, I receive the data from a user that wants to authenticate, I check if that user exists on the database, I check if the password matches, and if it matches, I will generate a session ID for that user. I will remember what was the session ID that I generated for that user, I save it into my session storage, and then I retrieve the user a cookie, and inside the cookie I have the session ID. What's the idea? That from now on, all of the requests that the user will send me, he will send me the session ID that I gave him. He will send me the cookie. And through that mean, I can identify that that request comes from the same user, and that I can keep track and store the application state even across different HTTP requests. Okay? So at this point, the server sends back an HTTP response containing a cookie with the session ID, and the browser receives the cookie, stores it automatically, so it is not something we have to implement. If our application, if our client receives the cookie, the browser knows how to store that cookie, and the web application handles the response, displaying welcome message. Okay. Is it clear, this process? Is it clear why are we using a session in this case? We want to keep track of which user is doing what, and we want to remember the previous request done from a user, and the way of doing that is assigning each of them a session ID, so that each time we interact, we will exchange the session ID, or the user will send me to the server the session ID so that I can keep track of his requests. Okay. Nice. So this is like the whole process, like the general perspective. So if we go deeper on what a session ID is, we can think of a session ID as a unique identifier assigned by the server to keep a session with the client. So for each client, I will create one different session ID. It enables the server to recognize that the client across multiple HTTP requests. So if each time that I receive the session ID with each request that you make, and I have stored the session ID, I can recognize that from who are coming each request. Okay. After authentication, the server sends After the authentication, the server sends a session ID to the client, and the client sends the session ID back to the server with every request during the session. It is stored on the client side and is sent automatically with each request, typically via cookies. And then we have the concept of cookies. So what is a cookie in this case? It's a small piece of information that is stored in the browser, that the browser knows how to manage in its internal cookie storage. It enables the browser to keep information across different requests and sessions, such as, for instance, the session ID, but the session ID is not the only case we are using cookies for, no? So in which other case, for instance, cookies are used to keep preferences, to track the users. So that's why the cookies, each time that you open a new website, is something so sensitive. Because by keeping track of the cookies, we can keep track of the behavior of the users of our web application. No? So for instance, when you are asked, do you allow the cookies in this website? It's because of that. It's because that website, by using the cookies, can keep track of all the actions that you perform on the website. Or he can keep track of all the actions that you, all of your search that you perform in the website, and all of the preferences and all of the behaviors in the website, okay? So this is why this is sensitive. And the browser automatically saves cookies received from the server. These cookies are automatically sent back to the server with each request to the same domain and matching path. So our cookies will just work in our domain. That in this case is localhost, because we are working on the localhost. And of course, the sensitive information should never be stored in the cookies. Let me show you something. Let's see if we are able to. Okay, so for instance, here in the Politecnico's website, we can see that here in the cookies, each time that we do a request, he stores some information, no? We can see what is the domain that the cookie belongs to, the path, and here we can infer, but we will see it later, that the cookies are composed by, it is basically a key per value, no? So here we have the key of the cookie, and here we have a specific value for the cookie. So it is not very complex information articulated in a very complex way, but it is just key values, okay? So the cookies corresponds to key value sessions. Then what does this represent? We don't know, because it's something that the server manages. So for the server, when the server receives, for instance, for this specific key name, this specific value, he knows how to manage that information, but it's not something that is explicit for the users in here. And here is something interesting to see, that as I was showing you before, the cookie has an expiration date, okay? So the cookie is not forever, but the cookies have a creation date and an expiration date. And then trying to integrate these two concepts of session ID and cookie ID, I think it's pretty clear how they complement, how they work together. So here we can think of the cookies basically as an envelope of the session ID. Okay? So the session ID is the information that the server has created to manage the user communication, to manage the interactions with the user, and the way of exchanging such information with the client is by means of the cookie. So a session ID is just a piece of data that basically represents a unique identifier that the server uses to recognize a user across multiple HTTP requests, as the ones that we can see here. And the cookie is basically the storage mechanism in the browser. So the cookie is the way to store small pieces of data, not just the session ID, but in this case that we are trying to implement the authentication is the session ID, what we want to send in the cookie. So the session ID is typically stored inside a cookie. So the process that we saw before in the diagram, that we saw that process conceptually, in practice should look like something like this, no? So that the user first sends his authentication credentials, then the server checks in the database if such user exists and if the password matches with the information that the user submitted. And if that happens, if the server can determine that the user exists and the password matches, he basically retrieves the response, the HTTP response, but such HTTP response comes with a cookie with the session ID inside. And from now on, this client, all the requests that he will be doing to a server, he will be doing such requests, adding always the cookie with the session ID, so that the server can identify him, can remember him, and basically can retrieve the resources depending on which user you are attending to. No? So I don't know, each time that I click on Amazon on the shopping cart icon, he retrieves me a response taking into account that I am the client that in a previous request added some item to the basket case, okay? Or each time that I open, yeah, the Amazon is the most simple one to illustrate the concept, okay? So far, everything clear? Questions? Okay, as we saw before in the console, in the Firefox console, what is a cookie, well, technically speaking, what do we have? Which are the attributes that a cookie has? So we have the name, that it was the first column that we saw there. So the name of the cookie, for instance, session ID. Then it has a value that is mandatory. The value is stored in the cookie. Basically, yeah, the value is like the reason to have a cookie. So in this case, as we saw also in the console, it's something that is not explicit. So most of the times it will be a code like this one that it is not possible for us to understand, but of course the server of such application is able to manage. Then it has like a flag that is secure, and if that's the case, the cookie can be sent just over HTTPS. It is HTTP only, and in this case we haven't seen already JavaScript, but if it has this flag set, it means that the cookie cannot be manipulated by a JavaScript script, but it can just be managed or sent through HTTP, and it has an expiration date, as we saw before. So this is basically consistent with this. With the name, the value, the domain, it has an expiration date, if it is HTTP only, and if it is secure. Okay. Let's see. So for instance, look at all of the cookies that Amazon stores just when you open the website. So it keeps track of a lot of information, and one of them is this session ID. No? So from the beginning, when you open Amazon, he creates the cookie, and he creates the session ID, and he starts to exchange the session ID. Even if the user is not authenticated, because here, as you can see, I'm not authenticated. Why do you think he creates the session ID even if I am not authenticated? Yeah?
I don't know, but maybe you can still add something to the card and it will remember it.
Sure. Because at the end, the session ID is the mean that we have to remember someone, to remember and to keep track of the request that a specific client is doing. So in this case, he wants to keep track of my interactions with the website, even if I'm not an authenticated user. Okay. So why? Because of that. Because he wants to, even if I'm not authenticated, if I add something to the cart, he wants to. And here it's why he asked the cookies and advertising choice. So if we want to enable him to keep track of the cookies, and well, just for. So yeah, in the basket case, he remembers my choices. Even if I'm not an authenticated user, he has some way to understand that that request has come from the same user. And each time that I do a new request to the website, the server remembers who is doing that request and retrieves accordingly, keeping track and remembering the choices that the user has done in the website. In this case, remembering that the user has already added one item into the basket case. Okay? Is this clear? Okay, so with this topic of authentication is particularly sensitive because if on our architecture we try to identify where are we when we talk about authentication, we might say something like this, that we are everywhere, that the authentication basically involves all of the components in our architecture, okay? Because of the diagram we have seen before, the authentication does not only concern the back end, but it also concerns the front end. Why? Because on the front end we have to do the validations, we have to check that the information that the user is sending is correct, we have to check, we have to hash the password, because we won't pass the plain password, but we have somehow to encrypt the password. So here it concerns the front end. Then on the request, on this part, of course, because it's what we have been saying today, that we have to deal with the sessions, we have to deal with the cookies, so that we have a form to keep track of the same user across different HTTP requests. Here on the backend, of course, we must create the session ID, we must remember the session ID, we must store the session ID somewhere. And of course, with the database, because at the end, when we want to authenticate the users, we have to remember the user's data, the user's information, and such data and such information is always stored in a database, okay? So this authentication basically involves or is transversal to all of the components in the architecture. So do we know the difference between authentication and authorization? The authentication is basically to know or to check who you are, what's your identity, okay? So this is typically done when using credentials like the username and the password. So it is just to understand who you are, and if you are registered, if I know you, if I know you basically. And it enables a personalized user experience. And then the authorization, what is? Depending or based on who are you, what can you do on my application, okay? So depending on your role, on your identification, I can give you some grants or some access to the functionalities of my application. So it basically depends on the authenticated entity. It grants permission to access resources based on roles, and I mean, they are not exclusive, but they must be used together to protect the access to a system. So first we authenticate the user, and then depending on the authentication of the user, I can authorize the user to perform some actions or to give access or to grant access to some specific functionalities. Question, important question. Are we going to implement the authentication and the authorization from scratch? Do you think it's simple to implement the authentication and the... No, it is not simple, because as you have seen before, we should be managing with creating the session ID, with keeping track of the session ID, with storing the session ID on the server, with creating the cookies, sending the cookie, keeping track of all of the cookies management. Then we have to verify on each request that the user is authenticated, that the user is authorized to do something, so it's complex. So on the one hand, as an implementation task, it's not simple. It considers, or it has to do with, it involves several considerations. And on the other hand, what's the most critical part? It is that we are dealing with the security. So if we don't implement something in the appropriate way, basically the security of our website, the consistency of our web application is threatened. So it's something sensitive, and it's something that is very prone to errors, because it's not simple. It is complicated, it is time consuming, we have to pay attention to lots of details. Sometimes this authentication might also require integration with third-party systems. So for instance, in those web applications that you have seen authenticate or log in with Apple, or authenticate or log in with Gmail, or So in that case, it involves integrating with third-party systems. It involves the client and the server, and it requires a lot of understanding of several new concepts. Okay, so the best approach, as we have seen before with some other components, is to follow the best practice and the standardized process by using or by building our functionalities on top of a well-implemented library. Okay, so not doing something from scratch, but to use a library to implement it. And in this case, we will use Flask login. That is an extension that manages the user authentication and the sessions handling in Flask applications. Okay. So if you want already to install Flask login, you can do it by running this command, that is pip install Flask login. By using Flask login, he uses the sessions to keep the users login. He handles very simply the login, the logout, and the remember me functionality. So it's something that we can invoke the functions given by the library to deal with that complexity. It stores the active user's ID in the Flask session. Okay, so as we saw before, that the server has to that the server has to store the session ID into the server session storage is something that Flask manages, that Flask login manages for us. And by using it is very simple to log in and log out users and to authorize users to specific routes of our application by simply adding a decorator over the function. We will see how it works. And to restrict the access based on the views and on the status, on the login status of each user. Okay. Okay. All right. First, let's see here in the slides, and then we will take a look in the implementation, how it works. So Flask login uses a class or a module that is called login manager. So once you have installed Flask login here, you will have to import Flask login into the application, and specifically at the beginning, you are going to implement login manager. The slides, I structured the slides so that it is like a set of steps that you have to follow to implement the whole functionality, okay? So here, first of all, you implement the login manager, and then we initialize the login manager in this way. This is basically a copy-paste. What changes in the application? Now it changes that we have to define this secret key. So for the application, in the configuration options, we have to set a new value that is the secret key. What is the secret key? It's some random string that will be used to sign the session cookies. So since Flask login will be dealing with the session ID and with the cookies, we want the cookies to be signed with a specific session ID. Okay? Making sure that the data sent by the client has not been modified. Okay? Question, why do you think, okay, I already told you and I already showed you that here this value is always kind of encrypted, no? It is not easy to read this value. Why do you think this value is sent like hidden or sent in that way? It is not plain, yeah.
To prevent session hijacking.
So to prevent?
Session hijacking, if someone gets the cookie and
Yeah.
use your session.
If I know your session, for instance, if instead of this code that is signed and that has been encrypted, it were like plain text, and if instead of, if I come here and I modify this cookie and here I set it to the session ID, for instance, the next time that I send it to the server will assume that this session corresponds to a specific user that I have altered there in this way. Yeah.
Also, it should be some like unpredictable encryption because I can see like my own cookie. So if I can, for example, the name to the value with some basic like base 64
Sure.
encoding, I can guess other.
Sure. Sure. Me as a user, as a client, if it didn't have encryption, I could be able to see what information it is exchanging, and I could be manipulating such information. So that's why in our application we create this secret key. That is an arbitrary string that we will use to encrypt or to change or to hide the plain data and to prevent the user to send the plain data, okay? Have you ever heard, I don't know if it's true, I don't know if that's true, but have you ever heard that there are some times in which it's more convenient to check for flights? For instance, when you want to buy a ticket for a flight, that they say that there are sometimes that it is better to check for a flight, or that you should always search for a flight, or when you are trying to to book a hotel room or something like that from a private window or from a private session. Why do you think it might be? Because by means of the cookies and the session ID, we can keep track of all of the behaviors that the user is doing on our website. So if, for instance, I am the airline website, the airline web application, I can see that the user is desperate to find a flight to travel this week somewhere, okay? And with that information, the response that I retrieve to his request can be altered depending on his behavior, no? If I say this user is super desperate to look for a flight, he has been asking me during the last week, in the last 3 days, he has been looking in the morning, in the afternoon for a flight. I'm not saying this happens, I don't know if it happens, probably. But what I could say is, since he has been behaving in this way, I can alter the specific data and the specific responses that I give to that specific user, okay? So, well, maybe one of the reasons they also keep this hidden is to keep us not aware of which data they are tracking from us and which information they are tracking from us, okay? And well, just as a curiosity, as a interesting fact, I have a friend of mine that works in a company, and they have like the online shopping platform. It is like for how do you say that? A sport brand, okay? And the other time he showed me that they have a kind of a dashboard, and in that dashboard they are able to identify each possible event that the user performs on the website. They keep track of each possible event. So they keep track of which links do I open, how much time did I spend on that specific link. If I open on a specific item in a specific pair of shoes, for instance, how much time did I spend taking a look at those shoes? And And the level of detail that they can track is super accurate and super tiny. It's not just that the user opened a website, but also when did the user open a website, what happened after, how much time did he spend on a specific screen, where did the user come from. So if the user came from Instagram, if the user was attracted by some specific network. So this data and this way of tracking the users is super powerful. Even if the mechanism is easy, is not that complex, but the power that this might have is super powerful. Okay, so that's why in this case we keep the secret key, because we don't want to pass the plain data in the cookies. And up so far we have this. Then we need to provide Flask login, always two things. So when we are implementing the authentication, we have to think of two things. One is the user model that basically represents what a user, or the user model is basically what a user represents in our application, okay? So we can decide what information do we store from a user, and in the context of our application, what a user is and which are the attributes of a user. This will make more sense when we implement that, and it can be based on any database system. And then there is another thing that we have to implement always when we use Flask login, and it is the user loader callback. And it is indicating Flask how he will load a user in our application, okay? So the first one is to give Flask login a definition of what a user is in our application, and the second one is to give Flask login an indication on how to load a user on our application, okay? Then the user model, by default, if we are able to set up those two specific aspects, our user model will have these properties. So it will have the properties to indicate us if he's authenticated, if he's active, if he's anonymous, and we can get the ID of the user. And this is all managed by Flask login. So for instance, from that point, if we are able to manage those two aspects, then we can say user.isAuthenticated, and we can know if the user at that moment is authenticated. User is active, and we are able to get in a Boolean response if he's active or not, if he's anonymous, and we can get the ID. So to build the user model, to build the first item, what we will use is we'll create this user model in a different file. So we will have a different Python file in which we say from Flask login import user mixin. And basically what we are doing is we are inheriting from this user mixin, okay? This is basically a copy-paste, but what we have to take into account is that this data, specifically the name, the surname, the email, and the password, depends on how we define a user in our application, okay? So for instance, in the application that we were implementing in Parato, we defined that, we said that the user in our application had a name. So it makes sense that here also to define a name. We also defined that it had a surname, an email, a password. But if, for instance, other than this, in our application, a user had, I don't know, a matricola, for instance, because we want to keep it just restricted for Politecnico students, here in this user model, we have to say, okay, we have to give a way to explain Flask login that in our application, a user has some specific attributes, and the matricola is another attribute that our user has in the application. Okay, So this one is basically a template or a way to indicate Flask login, that is the library, how a user is represented in our application, okay? And we do that by inheriting this class and by specifying here which are the attributes of a user in our application. Why do you think we have to do this? Because we can't assume that in all of the applications a user will have an ID, an email, and a password. Depending on each application, the users might behave differently, and we have to indicate the library how a user is represented in our application. And then, do you remember there were two things that we have to define? On the one is, the first thing is the model that we have just seen. And the second thing is that we have to define this function. That is the function load user, okay? What does this function have in particular, or why is different this function? Because it has this decorator here on top of the function. And this decorator is add login manager dot user loader to indicate that the function below is the function through which I'm indicating how to load a user in my application, where to get the data from a user, okay? Because as you remember, when we are doing the authentication, it concerns getting the data received from the client and somehow validate such data with the users that I have in my database, for instance. So here in this function, I'm indicating login manager where to get the users from. So in this case, where I'm getting the users from, or what I'm passing him, from the database, no? I'm saying each time that you want to load a user to check if the user is authenticated, if the user exists, you have to do this. You have to go check in the database the user by ID, and then if the user exists, you can get the user, you can create a new user class using the model that we created before, and then he returns the user, okay? So once again, there are two things that we have to create or to implement when using Flask login. One is the user model, and the other is the user loader callback. The user model is implemented in this way. It is just to define how a user is represented in our application, and the user loader is a function implemented in this way using the decorator to indicate how to retrieve or how to get the users in our application, okay? In our case, we get the users from the database, and from a specific database. Well, I can think of a different example, but maybe in other application, the way to get a user is not from one single database, but it's by doing requests on different databases. So in this case, you basically implement here or indicate here where are we getting the users from, okay? The users' data from. Is it clear? If these two steps are clear, it should be super simple. Questions? Okay. And if these two steps have been completed successfully, doing the login of a user is something as simple like this, like calling this function that belongs to Flask login, and we pass as a parameter to that function an instance of a user, no? So where does this user has been defined? It has been defined here. I've said, okay, now I will give you a new model, and in my model will have these characteristics. And then when I want to log in a user or to manage a user to do something, I pass him as a parameter by creating an instance of such model. So basically, how it works here is that I said Flask login I will send you an instance of a model using that inherits from the class that you defined, and then you deal with that user and you deal with that request. So logging a user, we should pass the actual user object to this method, and it basically returns true or false if it succeeds or fails. Okay. I don't know if you perceive this, but this way of doing the things is super easy, because we are not going anymore to check the username and then the password and then everything else, but we are just indicating what a user is, how to get the user, and since the Flask login already knows how to deal with that, then from that on I can just call the functionalities, passing the model, and Flask Manager manages it automatically. Okay, so this one is for logging the user. This one, how do you think this works?
Only returns the page the user is logged in.
Yeah, now we are protecting the roots. So this root won't be available anytime we go to Profilo, but it will be just available if the user that is doing the request to that specific root Profilo is authenticated. Okay. So, well, this is a root that requires the login. So, for instance, if in our application we had a specific root, a specific function for booking a new lesson with a tutor, we might expect that specific function to be login required, no? Because a user that hasn't logged in our application should not be able to book a lesson with a specific tutor. And then, similar to the login user, then we have the logout user. In this case, you can observe that here we are not passing anything as a parameter. Why are we not passing anything? How does Flask login understand which user to log out? The current one. And how does he know which one is the current one? Yeah, he keeps track of the user that has been created, and it also manages the cookie and the session ID and all of the data that he has created for the current user. Yeah, so since we already have a reference for the current one, he already knows how to manage that. And there is something super nice from the development point of view, and is that we can access the login user with this current user proxy. So if now you want to know what is the current user name, for instance, you can simply, in the templates in Jinja, say something like current user.name. No? So if the current user is authenticated, if we have an authenticated user, we want to show his name, for instance, in the navbar. That is typically what happens with the websites. After we log in, he shows my name in the navbar. So if I want to know what's the information or what's the data of the currently logged in user, from the development point of view, I can just say if current user.name, okay, or current user.id, for instance. And all of this is managed by Flask login. Up to now, is everything clear? Yeah.
So last week we talked about the become a tutor page.
Yeah.
And we talked about using the email to make so the application knows the user, but I think now it's clear that maybe it's better to put login required or something.
Ah, yeah, for sure. For sure, because since last time we didn't have like any resource to identify the user, we were saying, yeah, send me your email, and if I find that your email is in the database, I will let you to book the space. But of course, in real life, that wouldn't make any sense, because if I know your email, I write your email, then I will be booking in name of you. So it doesn't make any sense. So sure, here, this one solves everything. Yeah, of course. Okay, we'll see this in practice. But then there is just another thing that we must take into account, and is that when we want to create a new user, we don't want the password to be stored in the database in the same way that the user has written in the client side. Okay, so the password are never stored in the database in the same way. We have to apply some kind of hash to the passwords before storing them. So hashing is a one-way function, ensuring passwords cannot be retrieved from their hash. And in this case, we will also use a library that does that for us. So to install the library, you must run this command, pip install workseuk. And then basically what we can do is to use this function that is generate password hash, in which we will pass the plain password, and we will choose a method to encrypt the password. Typically, by default, we will use this one, a script. We won't deep on this because this has to do with security and that kind of stuff. But just for now, and for the purpose of and the scope of this course, we will always hash the passwords. Okay. Fine. Let me see if I'm forgetting something. Okay, up to now, any questions on the, yeah.
I don't understand the purpose of the HTTP only. Like, why would we want to manipulate cookies with JavaScript?
Because if my site has a script, a JavaScript, I don't know specifically like the scenario in which this can be risky, but it's something that, like, at the end, JavaScript is like a script that is running on the browser. So if the cookies are visible to the scripts running on the browser, they can do or capture or manage such information in different ways. So by keeping it in this way, HTTP only, it is just that the cookies are available and are manageable and are visible and are manageable by the HTTP request. So they are just intended for the HTTP communication. In the other case, you can say that they are also available for the JavaScripts that you are using in your website. Of course, that option would also make sense, because otherwise we wouldn't have that option of not being HTTP only. But in that case, I would say it is when a specific script wants to use such data for something. Indeed, for instance, the example that I gave you before of this online shopping platform, I don't know if it works that way, but I would say that they don't have this HTTP only option, because for instance, they could want the JavaScript to be running all the time, managing the information that they are getting from the cookies. So they don't use the cookies data just for exchanging information between the client and the server, but they want also to be capturing that information, and that JavaScript might be sending that data to a different server, or to, for instance, to the dashboard in which they keep track of all of the client events on the website. So for instance, in that specific case, is a case in which the cookies are not just for managing the communication or for dealing with the communication, but that they can be data that can be constantly managed and processed by a JavaScript script. Okay. Yep.
Actually, like one example where it's risky, I don't know if it's a general rule, but
Yeah.
like an attacker could put some JavaScript code into an HTML input field for a form,
Yeah.
and the script could say send the cookie to my machine, and the next time a user visits the web page,
Okay.
his cookie will be sent to the attacker.
Yeah, sure. At the end, sure, because at the end, the JavaScript is basically a programming language running in the browser. Okay, so somehow.
Probably you can avoid this with the input sanitization also,
Yeah.
so
Yeah.
I don't think it's a general rule.
Yeah, but at some point, if he can manage to get access to that data by running a script, it might be risky. Yeah. I'm trying to remember. No, I don't remember specific like security failures and security attack techniques, but yeah, I've heard something like that, like in the forums or something like that. You can manipulate the HTTP request and to manipulate the website to capture things. Okay, so what I propose to you is that we can stop here until 10, and then we will implement this to see how it works in the implementation, okay?